We're going to be starting the next session, the tissue chips in space session. And for that session, we're going to be shifting gears a little bit before lunch. I'm going to give a brief introduction to this tissue chips in space session. So it has been long known that in space, astronauts experience decline of certain functions. It happens quite fast in microgravity, and then usually upon return to Earth, those organ functions return to normal. And in order to study this phenomena, NCATS, in partnership with the Center for Studies of Science in Space, for Advancement of Science in Space, CASIS, partnered to start the tissue chips in space consortium, and it was quite effective. It developed some tissue chips, and those tissue chips were able to delineate some, recapitulate some of the findings observed in astronauts. And now we understand that aging is one of the most significant factors in progression of most common diseases, such as cardiovascular, neurodegenerative disease, or muscle weakness. But aging is very difficult to study on Earth. It progresses over time. It's slow. Developing clinical trials is very challenging. And therefore, we came up with Tissue Chips in Space program 2.0 in partnership with National Institute of Aging, Office of Research in Women's Health at NIH, and CASIS. The goal is to translate multi-organ chip system and use them for drug efficacy, toxicity testing, and personalized medicine, with particular focus on human age and aging-associated diseases. And we published this funding opportunity announcement. So these are technologically complex projects, these projects will develop complex organ systems that will model dysfunction in aging-related diseases at prolonged microgravity. Since those are technologically challenging projects, they will require multidisciplinary teams, including bioengineers, MPS, scientists, pharmacologists, and close partnerships with implementation partners. But ultimately, it will allow us to understand microgravity effects on human body and finding the better defined hallmarks of aging, and potentially will allow us to develop therapeutics targeting those conditions, and in particular aging-associated diseases. So we were happy to announce awardees for this Tissue Chips 2.0 cohort listed here. And you can actually see the QR code for the recent news published by NCATS. If you're interested, there is more details about this program and the awardees. And the awardees are their group led by Dr. Sitho from the University of Alabama at Birmingham, the group led by Dr. Mehi from University of Florida, team of Shrike Zheng from Harvard Medical School, team led by Arun Sharma from Cedars-Sinai, and team led by PI Dr. Joe Wu from Stanford, and finally Kerry German team from CFD Research Corporation. So we'll get to hear the presentations from these teams in this session. And we're very excited about those projects and looking forward to those exciting developments in this area. We're also looking for the ways to utilize the lessons learned from the Tissue Chips in Space program. And one of the lessons we learned that actually those microphysiological systems can be miniaturized and automated. And we came up with the program for small business companies, SBI, STTR, called Matches. It's focused on miniaturization and on automation of tissue chip systems based on the lessons learned from the Tissue Chips in Space program. And the idea is to develop turnkey technology with a smaller footprint, which will ultimately benefit the the broader biomedical community on Earth, and result was the adoption of those systems to be used by pharma and biomedical community on Earth. With that, I want to introduce, we're happy to have Michael Roberts, who is the chief scientist for the Center for the Advancement of Science in Space. And Michael will be doing welcoming remarks to our participants of this program, Tissue Chips in Space 2.0 cohort. Welcome, Michael.